A space mission like this has never been done before. Nearly 20 years in the making, and so precise that even a single millimeter of error could bring it all crashing down. Floating hundreds of miles above our fragile blue planet, two satellites move silently through the void, alone yet working as one. Their mission? To summon solar eclipses on command. Yes, you heard that right. This isn't science fiction. This is Proba 3, an ambitious mission that could completely revolutionize the way we study the sun, and maybe even how we understand our universe. But pulling this off? Oh, it's no easy feat. In fact, both NASA and the European Space Agency are holding their breath. Let's break it down. Proba 3 is made up of two satellites, locked in a breathtaking dance of precision and coordination. One of them is called the Occulter and the other the Coronagraph. Together, they're about to do something humanity has only dreamed of. The goal? Block out the sun, not from Earth, but from space. Why would we ever want to do that? Because in the blinding brilliance of the sun hides one of its greatest secrets, the corona. That ghostly halo we sometimes see during a total solar eclipse, that's the sun's outer atmosphere, and it holds answers to some of the biggest mysteries in solar science. Here's the catch. You can only see the corona during those rare, fleeting eclipses when the moon perfectly covers the sun. So what if we could create that moment whenever we want? That's what Proba 3 is here to do. The Occulter, the first satellite, carries a massive 5-foot-wide disk that acts like an artificial moon. It blocks the sun's light with incredible accuracy. And the second satellite? That's the Coronagraph. It hovers at the perfect distance to capture razor-sharp images of the glowing solar corona. Together, these two are trying to recreate one of nature's rarest alignments, on demand, in orbit. Sounds simple? It's anything but. These satellites must remain aligned within a margin of 1 millimeter. Think about that. That's about the thickness of a fingernail, all while floating in the vacuum of space with nothing holding them together. They're flying in a highly elliptical orbit, swinging between 372 and nearly 37,000 miles above Earth. But this orbit reduces the gravitational pull of Earth, so the satellites don't need to use much fuel to maintain their delicate balance. Oh, and how do they stay connected? Not with wires, not with constant ground control, but with lasers. That's right, they use laser communication to adjust their positions in real time. This has never been attempted before at this level of precision. And if they succeed, it's going to change everything. Imagine a future where satellites fly in perfect formation, like birds in the sky, working as one, acting like enormous telescopes, or planet explorers, or even solar shields for Earth. That future starts now. The Proba 3 mission also has a secret weapon, a device on board the Occulter called DARA. Its mission? Measure the sun's total energy output. That data is crucial. It helps scientists understand how much solar energy reaches Earth, which has massive implications for climate studies. This isn't just about the sun. It's about understanding the forces that shape life itself. The mission itself is historic for many reasons. For one, this is the first time the ESA has launched a mission from India since 2001. The spacecraft was built by 13 European nations, and even Canada joined in. But it wasn't all smooth sailing. There was a hiccup. The air freight company responsible for transporting the satellites initially refused. Why? Because the batteries were still inside, so engineers had to quickly remove them and ship the batteries separately. Not ideal. But hey, nothing worth doing ever comes easy. The dream for Proba 3 began back in 2005, when scientists at the ESA first came up with the concept. And now, after nearly 2 decades of dedication, planning, testing, and faith, it finally launched on December 5th, 2024. For the first few weeks, both satellites stayed connected as engineers tested every system, every sensor, every control. Then came the moment of truth. On January 14th, 2025, the two satellites gently separated, and that's when the real mission began. In their first image, the coronagraph captured a glittering star field in the constellation Ophiuchus, a small but powerful sign that things were working. And that was just the beginning. 2025, it turns out, is going to be the year of space missions. Get ready, because this journey is about to get even more exciting. Let's talk about what's next. IMAP, the Interstellar Mapping and Acceleration Probe. Scheduled to launch in September 2025, this mission will venture to the very edge of our solar system and beyond. Its mission? Explore the mysterious boundary where our solar wind meets the vastness of interstellar space. It's like standing at the edge of our backyard and peeking into the dark forest beyond. IMAP will help us understand how the solar wind behaves and how cosmic rays filter through that boundary. This is deep space science, and it's mind-blowing. Then there's Punch and SphereX. These launched earlier in March. Punch will monitor solar winds and help us predict dangerous solar storms before they reach Earth. Think of it like a space weather forecasting system, because space weather can knock out satellites, power grids, even airplanes. SphereX, on the other hand, is mapping the entire sky in infrared. It will gather light from millions of galaxies, potentially unlocking the secrets of the universe's earliest moments after the Big Bang. But wait, there's more. Tianwen-2, the Chinese mission set to launch in May, will visit an asteroid named Kamoholwa. What's so special about this rock? Scientists believe it might be a lost fragment of our own moon, blown away by a massive impact eons ago. Now it orbits the sun, and soon we'll pay it a visit. And then comes Escapade. 2 spacecraft, 1 goal, Mars. Escapade is all about understanding how solar winds eroded Mars's once thick atmosphere. That's right, Mars was once like Earth. Wet, warm, maybe even habitable. And then it became a cold, dry desert. Why? Escapade might finally tell us. Of course, 2025 is also shaping up to be the year of the moon. The IM-2 lunar lander already reached the surface on March 6th. Its goal was to search for water ice near the moon's south pole, a key ingredient for future lunar settlements. But things didn't go as planned. It landed sideways. One of its antennas failed. The solar panels couldn't generate enough power. And by March 7th, the mission ended. Disappointing? Yes, but far from the end. Later this year, the Griffin lander will take its shot, aiming for the Nobile crater. And in late 2025 or early 2026, the IM-3 lunar mission will launch with a whole suite of science experiments. Then there's the icy frontier, Europa. NASA's Europa Clipper is en route to Jupiter's icy moon. Scientists believe Europa might have a salty ocean beneath its crust, maybe even life. On March 1st, it used a gravity assist from Mars to gain speed. On August 31st, ESA's JUICE spacecraft will swing by Venus, one more step on its long journey to Jupiter's moons. As for Juno, the spacecraft that has given us jaw-dropping images of Jupiter since 2016, its time is almost up. By September, it will end its mission with a dramatic dive into Jupiter's atmosphere. All of this is just the beginning. Proba 3 isn't just a mission, it's a symbol of what we can do when nations work together. When engineers, scientists, dreamers all aim their hearts to the stars. We are learning to master space, not with brute force, but with elegance, precision, and purpose. We are beginning a new celestial journey, and it's happening right now. So keep your eyes on the skies. Because here at KM Celestial Journey, the cosmos is just getting started.